Good morning. It is our pleasure to welcome you to the second day of two days webinar on artificial intelligence and model-based design using MATLAB. And I welcome on behalf of Chennai Technology. And it is our great pleasure to welcome you all the participants as well as the today experts of the MathWorks to this wonderful forum. I welcome you all for this wonderful forum.
Thank you.
And today we have Mr. Vinay with us, and we have Dr. Spandhana with us, and we have Mr. Nikhil with us, and we have Mr. Agil with us. Yeah. So since it is a second day, so straight away we will go enter into the presentation. So please, you can go with the sessions.
I request you for a few minutes, so that other participants also can join. I think we can reach 300.
I think can be started.
Yes, we can.
Okay. Well, thank you everyone for the introductions. My name is Amit. I'll be doing most of the talking today, along with my colleagues Spandhana and Vinay and Nikhil. So we're gonna try something new. So Spandhana is gonna sort of be like the faculty advocate in some way for us, and then she's gonna keep asking questions every now and then, hopefully which match your questions, you among the audience, and then we'll see how that goes. And depending on what questions you ask in the chat window on the right-hand side of your screen, we can sort of bring that up as well and try to address those questions too. All right. So with that said, hopefully my screen's visible and my voice is loud enough. If it's not, please let me know and I can modify accordingly. Okay. So for the next 1 hour, the agenda is we have 4 sections. We'll take some more time for Q&A, but these are the big 4 points here, where we'll sort of give some background about the MathWorks, talk about computational thinking, given that now sort of online teaching kind of situation that all of us are in, we'll try to talk about how to maintain student engagement remotely. And then finally, we'll go into some auto grading tools that are available for you to try to teach these courses better. Okay? Again, during the presentation, please ask questions in the chat panel, and we'll periodically check and answer anything that we have answers for at the moment. Right. So without any further ado, we'll jump into some background of the MathWorks. Right. Okay. So MathWorks is a global sort of company. It's headquartered in Natick, which is right here. If you can see my screen and mouse pointer, we have 4 offices in India, and we're growing. There are more than 3 million users in several countries. In fact, currently we in fact reached 5,000 staff members in various offices, and these are all the locations that we have offices in. So I've personally been at the MathWorks for a little more than 7 years now, and so it's been great, right?
Amit, I have a question.
Yep.
Sorry for interrupting you.
Oh, that's fine. Yeah.
I've heard about MathWorks.
Yep.
What is the difference between MathWorks, MATLAB? What is the difference between these two?
Yes, great question. Thank you, Spandhana. So several of you may have heard of MATLAB, right? But may not have heard of MathWorks, right? So MathWorks is the company, name of the company, and MATLAB is the name of our one of the names of our tools. Okay, which sort of leads us to the next slide here, where you may have heard of MATLAB, right? So MATLAB is the product, and MathWorks is the company, right? So speaking of MATLAB, really, it is an environment, we call it an environment for technical computing. So essentially doing things like data analytics or numerical solutions or visualization of your complex systems and so on. You can do that very well with this kind of tool, right? Which some of you may be familiar with already. There's another tool which is called Simulink. The idea is if you want to simulate complex systems, and we looked at this earlier yesterday in our webinar, where it's kind of a block diagram environment. You can do time-based simulations of systems. In this case, for example, a lane marking system and so on. So Simulink is another tool that we have. So that's sort of the big difference between the name of the company here, the MathWorks, and MATLAB. So MATLAB, in fact, stands for Matrix Laboratory. So that's the full form, and this is a short form of the of the name, right? Cool.
So I've now understood that there are two big products, MATLAB and Simulink. So are these used only in the academia, or are they also used in the industry?
Right. Great question again. So so looks like so several of you who are attending here are academicians, right? So the question is it used only in academia or also in the industry? And so there are several different types of industries that use MATLAB, right? So for example, Airbus in the aerospace industry, Subaru and Toyota in the automotive industry, a lot of bio, pharma industries, communications, all of these industries have some or the other requirement for the use of MATLAB. So you may now be thinking, okay, this is great. Industries use MATLAB, but why should I, as a faculty or an instructor, want to teach this, right? So really, along those lines, the point really is that students who learn MATLAB early on and have this kind of understanding of how to program and how to develop systems and models in MATLAB really end up getting jobs in these companies who already use these tools, right? So, for example, companies that might be familiar to you are maybe Cognizant, and then Bosch, Amazon, Google, National Geographic. There are a lot of relationships between companies and universities, right? So, for example, in our experience, we have seen universities tie up with some of these companies, like Bosch, for example. There's a tie-up between a university here in India and the company, and so when the students learn these tools in their third or fourth year, of their undergraduate degree, they then go on to sort of have a leg up as compared to other students from other universities, right? So that's really the advantage and the need for using MATLAB in these industries.
So are there any Indian companies or that use MATLAB? Because most of probably students from India end up getting jobs in India. So how many of these companies do hire our students?
Right. So for example, the big Indian names here potentially are Cognizant, Capgemini. Continental has big offices in India. I've not included the logo here, but KPIT is a big company in India that uses a lot of MATLAB for their automotive applications and so on. And so KPIT also, for example, ties up with universities, and they have these, for example, they can sort of run courses in final year of undergraduate degree, for example, and then sort of automatically get the best performers in the course get to interview with the company and things like that. So there are great industry academia collaborations that happen within India too, where this kind of learning these tools early on is a great idea. Right?
I see Cognizant present here, so most likely other service companies like TCS, Wipro are also MathWorks customers, is it?
That too, yes, you're right, yes. So speaking of that, really, so MIT Manipal University on the west coast of South India. So they've actually taken a step forward, and they've done this for a while now. It's been easily 5+ years since they've done this integration of MATLAB and Simulink into their curriculum, right? They've purchased this thing called the campus-wide license. And in their first year course on problem solving with computers, they introduced MATLAB and C. So the idea is that when you're introduced to MATLAB early on in your curriculum, you can be much better prepared for higher studies. You have a competitive edge, and then you get a much broader set of skills to work with, so that you can get placed in these companies listed above, for example, right? So that's sort of the whole idea of this sort of webinar today, is to try to figure out if there is space for you to include MATLAB in your curriculum, and for your students, or if you're a student already, for you to sort of pick up these skills as you go early on in your engineering career, right? So that's really the idea.
Thanks for mentioning that Manipal has introduced MATLAB in the first year, which is awesome because they end up using MATLAB in second, third, and subsequent years as well, right? Including their postgraduate education, irrespective of where they end up in the world.
Right.
This is really awesome.
Right. Yeah. So really, like we saw earlier yesterday, right? So the application of MATLAB is not only for one course or one topic, right? So if you're an electrical engineer, you can learn control systems much easily using the block diagram tools. If you're a computer science engineer and you're focusing more on AI, we have apps and tools to do that more easily and focus on the concepts rather than worry with the code, right? If you're into civil engineering, there are fluid dynamics models and hybrid mechanical systems that you can develop. So it's a really broad sort of solution space that we can target. And given that it's one integrated environment, it's easy to learn these interdisciplinary skills, right? So let's say a civil engineering student wants to learn robotics. For them to learn it through MATLAB is much easier because it's abstracted well enough, rather than for them to have to learn C programming and then go all the way up to some obscure library that they'll have to pick up, because the transfer of knowledge between what they already know in their domain and bringing it into this new domain in MATLAB becomes much more easier, right? Yeah. So really, there are, we see these three big sort of pillars in the engineering sort of academic kind of space, right? So the one that we've spoken about quite a bit already is undergraduate education, where the focus is to build the workforce, right? And building the workforce really is sort of targeting either these students go into research universities for higher studies, or they go into the industry where they do applied research or product development, or be part of services companies and so on. So these are the three big pillars, and so there are these very strong connections between them, right? So like we spoke earlier, from undergraduate education, the people go into in the industry and be part of the workforce. There's a lot of very essential fundamental knowledge that people gain here that then is absolutely essential to take more advanced courses and then start doing new discovery in your PhD area, for example, right? And then these two are connected too, where new a PhD student's thesis might be commercializable, right? So then that can become a new innovation and go into the industry as well. So we think that the MathWorks sort of sits right in between these three pillars, that the earlier on you pick up these tools and that you can get yourself familiar and start thinking at the level of building something in an engineering system, the easier these transitions can be, and the faster you can innovate in this sort of cycle too, right? So that's sort of the big picture idea. And we have dedicated teams at the MathWorks who support both industry and academia. So you're not alone in your quest to do all of this. There are teams at the MathWorks who can sort of help you navigate through these. Some of us, in fact, have been through these loops ourselves, right? So I learned MATLAB in my second year of undergraduate program. Spandhana learned it quite early too, and so we sort of have some experience in this, and we can sort of guide you to do this better over time, right? Cool. So here is one specific example of. In fact, Spandhana, you probably have been more involved with these guys, right? So can you say something about how this came up
Sure.
from IT
Thanks
Madras?
for inviting me to talk about Aether Energy. Aether Energy is a company which developed the electric two-wheel scooter and also the charging stations. And they used a concept known as model-based design. We talked about it in our yesterday's webinar, so I'll not get into the details about model-based design. So basically, their challenge was to design and produce India's first electric scooter. And how did they do it? These guys, they come from IIT Madras. This company was incubated in IIT Madras Research Park and Startup Research Park. So IIT Madras has been one of our first IITs which has adopted MATLAB campus-wide license, and they're also they're very well represented in student competitions and so on. So the same people who were undergraduates at IIT Madras and participated in student competitions went on to found a company and incubated in their own university, and finally you must be seeing these scooters now. They're out in the market and they're being sold. So they used the concept known as model-based design to simulate and optimize their design and generate what is known as production quality code. And MathWorks has been very much involved in this company through our consulting teams and our AE teams. We have done multiple projects with them. And with this, we've been able to achieve reduced testing time and also deploy the scooter faster in the market. So this is one success story that we call, which spans the entire ecosystem from undergraduate education to a company which is now producing a product that is in the market. So thanks, Amit, for inviting them. And this is really impressive what they've been able to achieve given the Indian scenario.
Yep, cool. Thank you, Spandhana. And if you'd like to learn more, there's a link here that later on we can share the presentation with you. And then you can, or you can even just Google Ether Energy MathWorks, and you can find a longer story about how they really got to do this, right? So really, one of the things that Spandhana mentioned that's important is I think she mentioned how quickly they simulated and optimized their design, right? So if you take a step back from there, really the point is this, right? So there's this term called computational thinking. The idea is, these days, fortunately or not, everything that we do virtually is in some way related to computer science and coding and sort of building something on your computer, right? The problem there is we tend to spend a lot of time how to learn to code, right? But that's not really the end product that we want. The end product we want is to do the learning better and not to do the coding part better. The coding is sort of the means to the ends, and the end is actually learning. So computational thinking really, and this is a quote from a professor at Carnegie Mellon, where they say it's a fundamental skill not just for computer scientists but for everyone, right? And the impact or the idea really is to start thinking in a logical manner and to be able to do that without having to worry about the nitty-gritty details of code, right? The reason why some of these languages these days that are not C, C++ are getting more popular is that you don't have to worry about memory mapping and garbage collection and these things that are very computer sciencey terms, which are in some sense solve problems that undergraduate students may not need to have to take pains to learn about. Whereas they can focus more on the concept itself, they can focus more on the topic itself, right? So that's what we mean by computational thinking, and in fact, MATLAB is a great tool that helps you reduce your time and effort investment in these low level things, and starts letting you think at this higher level concept picture, right?
This is a really great concept that you just introduced about computational thinking. As faculty members, what can faculty members do to adopt this in their own courses?
Right. So here are some of the tools that we have to sort of encourage faculty members as well as students. So we understand faculty members sometimes also need encouragement to include or to develop these things. So here are the three specific buckets we have some tools in that you can hopefully get encouraged to start introducing these to your students, and for your students to pick these kind of concepts up the right way. Okay, so thanks for bringing that up, Spandhana. So we'll actually jump right into the first one here, in the interest of time also, to sort of show you how to come up with or how to build these tools for computational thinking. The first one is, so we'll try to do this demonstration here. Let me make sure that, okay, so you can see this here. So I'm going to reset this. Hopefully, no, I'm not going to do that. So hopefully you can see the screen here and it's not distracting. So this is a problem called the Monty Hall problem, right? The idea is this. So we don't know if you've heard of this in the past, but I'll try to quickly elaborate how it works. So there are 3 doors, and behind one door there is a car, and behind 2 doors there are goats, right? So your objective is to sort of win the car if possible, right? So what you can do is you can choose one door to begin with. So let's say I choose door 1, and then once I do that, the game show host or the person who's running this show will open one of the other 2 doors, right? And then one of the other 2 doors that they open will have a goat behind it, and so the choice you have is, do you maintain the choice of your first door, or do you switch to one of the other doors, right?
Amit, I'd
So
like to run a poll here. Let's see what the audience wants to do.
Yeah.
So the question is, I hope everybody understood. So you've chosen door 1, and the game show host is going to pick one of the 2 doors. Let's assume that the game show host picks door 3. That
Yeah.
means there is a goat behind door 3, right?
Yeah.
So you have an option to either stick to door 1
Mhm.
and hope that there is a car behind door 1, or
Yeah.
you switch to door 2.
Yeah.
So this is the poll that I'll be running. Please pick which option would maximize your chance of winning a car. That is, either stick to door 1 or switch to door 2. So you should be able to see a poll right now. So let's see what the audience thinks the answer is. So as of now, it's standing 50-50, which is what I
Interesting.
thought when I was a student. But that is not the answer.
So it looks like it's hovering around 50-50, which is interesting. Can you see how many people responded to the poll, Spandhana?
Unfortunately, I don't have that number.
Okay. That's very interesting. So let us run one of this one run of this, right? So let's say I choose door 1, and now the host is going to choose one of the other doors. So they chose their second door, right? And the second door had a goat behind it. Now the choice is: do you still stick to one, or do you switch to the other door, right? So looks like at the moment it's 51% stick to door 1. So I'm going to choose this. So you see, in this case, it so happened that the other door had the price, right? You can reset and then try again, right? So let's say this time I choose door 2 to begin with, and then another door gets opened. So this time, let me not switch. Actually, last time I did not switch. So this time, let me try to switch the door and see what happens. So I switch, and this time, hey, I won a vehicle, right? So the big picture we want to show here really is there is fairly deep mathematics that goes behind this. So this is, in fact, the concept of conditional probability here. The Monty Hall problem is a great way to sort of demonstrate conditional probability to your students, right? If you want to really find out what is better to do, whether maintaining the door or switching is better, you can actually run a simulation for it. Okay, so I'll actually try to bring that up here very quickly. So if you can give me a moment, right here. So this is MATLAB, and this is something called a live script, right? So you can sort of explain what the problem is, and then set up some parameters. Let's say I have 3 doors here.
Amit, one favor, can you maximize your screen, please?
Yes, yeah.
And also probably increase the size. Yeah, thank you.
Yep. Cool, thank you. Right, so it's called a live script, and then you can sort of execute your code, include instructions, describe what the problem is, and all of this in one document, right? So what we've done here is we've, pretty much what we looked at earlier. This is in the code form. And then here's some, we can't run through all of this in the interest of time, but there's something called Monte Carlo simulations, where essentially, what if you ran this experiment 10,000 times, right? And then found out which choice really helped you win more often, right? So you can set up like, how many times you're repeating this. Let's say we repeat 100 times, and then you can run the entire code, and then you can see that if you switch the door, you win 68% of the time. If you don't switch the door, you win 33% of the times, right? And then you can, increase the number of times you run this, and so you can probably get a clearer, better representation of the probability, right? More accurate representation. And so
So
the
the
idea is,
answer is actually it would have been better if you switched the door.
that is right. Yes.
Okay.
So based on these numbers here, right? So you can see clearly that the percentage of wins after switching is always constantly higher than when you don't switch, right? And in fact, it's 2/3 versus 1/3, right? So 67% or 66% is sort of very close to 2/3 as compared to not switching. So you can sort of experimentally and sort of with simulation show that switching is better. And in fact, we think that this way of demonstrating or teaching basic mathematics is much more enjoyable and much more intuitive and understandable than just equations on your whiteboard. Right? So that's sort of the idea, really, is to make use of these tools that we have. So this thing really, and I didn't mention this earlier, this thing that we built is called the MATLAB app, which you can see here, hopefully. And so you can build, so this is a custom built app. So we built this for this particular problem. This thing here is called a live script, right? The cool part about this live script also is you can very easily save it as a PDF file, which I've done here already. So you can save it as a PDF and share the PDF file with your students as well. And it'll include all the details here too, including code that they can rerun on their computers if they'd like, and the explanation that you have, and so on, right?
I have one question. If I'm teaching math, I have a lot of equations. Can we write equations in this thing?
Oh, yes, absolutely. Yes. Thank you for bringing that up. So in the live editor here, hopefully this is kind of visible to you still, even though the font size is small. There's an equation editor, so you can in fact include mathematics equations here and have integrals and a whole bunch of equations that you can sort of set up very quickly. If you're also interested, there are all of these symbols that you can use. The thing that I want to also show was if you're interested in LaTeX equations, there's also you can enter LaTeX code and then it will sort of render it into equations and add it here automatically. So that's a great point, Spandhana. So really, your mathematical equations as well as its equivalent code can be put into this one file here for everyone to understand things better. Right?
We have one question from the audience. They say they want to know what is MATLAB app and whether it can be downloaded from the web.
Right. Great question. Thank you. So an app is sort of an interactive interface in some way, where you can sort of press buttons and sort of interact with this tool, right? You don't have to write code per se in an app here. The way we built this, it comes along with MATLAB, so there's no separate installation required. The way we built this is through this thing called the app designer. Okay, so we have a tool where you can interactively, drag and drop components, buttons, checkboxes, pictures, and so on. You can build an app here, right? And this comes along with MATLAB.
Just a
In
favor, could you
addition,
also demonstrate?
if you look up here, yeah,
So sorry, could you also demonstrate what other apps we have?
the app. Yes, absolutely. So in this tab here, if you look at the apps section, there are several apps that we've built on our own, right? That you can use directly. So you don't have to build things from scratch. So for example, one of my favorites is this one here called the Deep Network Designer, right? If you're trying to build a deep neural network, like Spandhana was talking about yesterday, right? This app will, once it loads, will make it easy for you to build these networks very quickly and analyze what's happening with it. Okay. Not sure why it's taking so long to open.
Do we also have any apps for optimization?
Yes. So let me go back there. So for optimization, we do have apps. I haven't installed it on my computer, but we do have apps over here for optimization as well.
Okay, thanks.
So this is the Deep Network Designer, where let's say you can open ResNet 50, and then you can see ResNet is one of the deep neural network architectures that we have. And so you can open it and sort of visualize and see how it looks, drag and drop layers and things like that, right? It's taking some time for whatever reason on my computer now, but it should be fairly quick when you try it.
So how difficult is it to build a custom app? How much coding should I know to build something like that?
Right. Great question again. So if I take this example, let me go back to here. This one, it isn't much. It's slightly complicated, meaning that you'll have to know a little bit of MATLAB programming. This app that we built here, the app with the 3 doors, this is the code. It's not rocket science. It's fairly straightforward. Once you kind of learn the logic behind how this kind of problem works, it should be fairly straightforward to build it. And we in fact have sort of guides and markers, and this is the callback for this button pressed. So add code here so that you know that this code will run when this button is pressed, and things like that. So it's very, very intuitive. So it'll take some time, but then once you get used to it, it'll be fun.
MATLAB language, or is this in some other language?
This is in MATLAB. This is entirely in MATLAB, and in fact, the design view is great. So you might appreciate this. So you see, I'm just let's say an image. If I want to add an image to the app, I just drag and drop an image here, and then resize it and organize it in a way. There are all these guidelines that come up to position these, right? So it's really, really simple to do this. Once you do this, you can then go into the code view and then look at the code gets updated based off of whatever we add and build here. So it's very intuitive, and we have in fact tutorials. So it's not that these things exist on their own. If you look at our website, there will be tutorials that show how to get started with this. And obviously, we're around. So if you want to use this and you're not entirely sure how to do it, we can help you out as well. So there's a lot of support that comes your way along with this too. Right?
Thank you.
Yeah. Cool. That was a great discussion. Thank you for the great questions, everyone. So that was really a quick demonstration of how to use these computational tools, right? Really, the things that we saw was the live editor, where you can have the outputs, the code, instructions, and text and so on in one file, and you can sort of create reports and show everything you want to show in one file, right? We then saw interactive apps. So this is the app designer. Here's in fact the website for app designer, and if you dig deeper, you'll find some videos. And so if any of you are interested in building these apps for your own students, for example, please do get in touch with us. We'll be happy to help you and show you more details and links about this. Okay.
I have one point, Amit. With
Yeah.
respect to app designer, I see that a lot of professors are considering app designer for this online mode of teaching nowadays, especially because students don't have access to labs and they want to build something as a virtual lab for students.
Right.
And that is something that everybody can explore, given that I think next few months is going to be online mode of instruction, right?
Right. Yep. And also, there are there's this thing called File Exchange on our website, where it's a community of other professors and other people who built apps and shared them, right? So you can then consider using those apps that people have already invested time and effort to build in your classroom. So it's not that you have to start from scratch all the time. There are apps that we've built that are part of the tool already for various different applications. And if you don't find any here, there are apps on the File Exchange. And then if you don't find anything there, then maybe you can sort of consider building something on your own. So we've, for example, built an app for convolution, for modulation in the electronics domain, and so on. So there are lots of them out there. So do consider exploring this option. Right? Cool. The other thing that we didn't mention so far is this. So there's actually entire courses that other professors have developed using MATLAB. The content for which content including lecture notes and code and project ideas and so on in various different topics are also available on our website here. So if you're teaching any of these courses and you want to get started with some material, please feel free to browse these. And these are royalty free, so you can use them in your course without any royalty as well, right?
I have another
Yeah.
question,
Yeah.
with regards to MATLAB courseware that you just mentioned.
Yeah.
It's great that there's so many courses that are available. I can download it and use it, but most of the time, like faculty members don't have enough time to get ramped up on these material or MATLAB itself, for that matter. Like they don't have time to incorporate a new tool in their courses. So, do we have any solution for them?
Right. Absolutely, and that's a great point. We have, and I might come to that a little later. We have some sort of training. I wouldn't say training, but these online courses to get started with several of our tools. You may remember from yesterday that Spandhana mentioned these on-ramp courses. I'll get to that in a bit. I think. Yeah, so that's in one of the latest slides that we have, where there are these 2-hour courses that we can sort of show you how to get started in several of these tools. So that's a great question. I'll come to that in a bit. But here, for example, in addition to the courseware listed here, there are more specific pages for specific topics too, right? Like if you're teaching calculus, there is a page for that. And then there are code and videos and things like that for each of these topics. So please, if you're interested, Google teaching whatever subject you're teaching with MATLAB, and then quite likely you'll find a lot of material for it already. Okay. All right. So I'll move through this a little more quickly, and it sort of also tries to answer one of the questions that came up. Is if I want to get started very quickly teaching things with MATLAB, how do I go there, right? So really, in terms of student engagement, what we've done so far is also trying to show that learning by doing is much better than learning by listening in some way. You try to do it on your own, try to test things out on your own, and then learn from the mistakes you make, and then you sort of improve, right, iteratively. This is really engineering science in its true sense, right? You try an experiment, it fails, okay, you tweak something, and then you try again, and so on. So that's really how we think student engagement goes. And to answer Spandhana's question, here are a bunch of free online courses that you can get started with. If you or your students are absolutely not familiar with MATLAB as a programming language, here is a 2-hour course for you, right? They're all, in fact, available in this particular link here, and they're free, and you get a certificate once you complete it, right? So that's really very cool, and you can put it on your LinkedIn or your resume or wherever else you want to showcase this, right? So there's one for MATLAB. If you're interested in the model-based design thing, there's a Simulink course. If you're more interested in the AI space and you're a computer science kind of major, you might want to look at these two. Stateflow is, like we discussed yesterday, sort of state machine simulation kind of framework. In fact, these two, Simulink and Stateflow, require Simulink to be installed. These three, MATLAB, machine learning, and deep learning, can be run online without any installation, right? So I'd encourage you to please look at these. In fact, in addition to these, if you do subscribe to our campus-wide license program, there are additional courses too, and they are much more involved. Some of these are courses that are specific to mathematics topics. There's more. This is like a MATLAB Fundamentals, a 14-hour course, which goes deeper than the on-ramp course into more programming methodologies. Here's another course on sort of programming techniques itself. Again, I believe it's like 14 hours long. And so all of these are included as part of your online training suite if you do have a campus-wide license program, of which, like Manipal and Kaylee Tech and several other universities across India are already subscribed to. And in fact, some faculty use these courses as part of their actual course, right? So you can have your students finish this course and share the certificate with you, and then you can award them some credit. Let's say 10% of your course credit comes from completing this part, right? And this is, again, entirely online. So it really helps you move faster into this online mode of teaching as well, as long as these topics are what you want to teach, right? So, going forward, if you're working with hardware, for example, there's this thing we spoke in some depth about yesterday called project-based learning, where the idea is, you can sort of combine mathematics and computation. In fact, both of these can live in a live script, but you combine these, and then you sort of use low-cost hardware. This is an Arduino Uno board, and then you can sort of build things like this, where it's a bot that kind of, given an image of an object, can sort of try to draw it using this marker right here, right? So you can do interesting, fun things like this using hardware as well, and also MATLAB supports easy deployment to these boards too, right? So again, we saw this yesterday, but just to reiterate, Kaylee Tech is a university in Hubli in Karnataka, and they've also, in their first-year engineering course with 1,200 students, run courses where they build these sort of line-following robots as part of the course, right? And then they have this other, you may notice Simulink here, and they have all this hardware that's connected to the computer at all times. And so you can do things like hardware in the loop processing and so on. The idea is something called experiential learning, where you learn by doing, right? And you sort of acquire something called the joy of engineering, which we all hope to get over time. These are videos. I'm not gonna actually. I can play one. I'll turn off the noise. But where you see, they're sort of building this line following robot that can go along this kind of map here, and I'll turn off the volume here too. You can see, state flow, in fact, right here, interacting with hardware, sort of hardware in the loop in some sense, right? So you can see the states changing here. Right? So really, first year is a great time to introduce all of these tools. Is the point we're trying to make here? Okay. So really, hardware trends. If you don't have any of these boards handy, phones are great hardware platforms too. Most of us have Android or Apple phones, and so there are these things called support packages where you can use your Android phone sensors as your inputs, and then you can sort of build programs to run on your phone, and then do interesting things like image processing and things like that, right? So in terms of hardware to be integrated in your teaching, there are a lot of tools that we can make use of as well.
So how, I have one small question.
Yeah.
How can you use mobile phone sensors and collect data? Is there a way?
Yeah. So in this slide here, what you see is something called a Simulink support package for Raspberry Pi, right? So if you remember the model-based design presentation we did yesterday, Simulink is sort of this block diagram based environment where you have these blocks that you can connect and so on. If you notice, hopefully the text is clear here. There is Simulink support package for Samsung Galaxy Android, right? And things like that. So there are blocks like these that are sort of configured in a way that can acquire data from your Android phone directly, right? Here, for example, there's audio capture for Raspberry Pi. There's something similar for Android devices too. And you can use these blocks directly in your Simulink model, and then generate code that can run on your phone itself. So we have an entire workflow of how you can do this. And once you know what blocks are available, the sky's your limit then, right? So you can build whatever it is that you want using those. For example, accelerometers are sensors that you can acquire data from your phone. There's also this other thing called MATLAB Mobile. I'll come to that in a bit. Right. So this thing here is Raspberry Pi, and there's this thing called Thingsspeak. So Thingsspeak is this IoT platform where you can connect a bunch of sensors and run some kind of analysis on it entirely on the cloud, right? So if you're teaching Internet of Things, or if you're interested in working on projects in this area, we have this great platform which we know a bunch of universities already use. For example, if you want to build a weather monitoring station, or you want to track traffic in a particular region, right? You can build an Internet of Things kind of platform, and then collect and analyze data using this thing here, right? And you can do that with hardware, Arduino and Raspberry Pi, and so on. The other thing, the sensors thing, Spandhana asked, is right here. So there's an app that you can use with MATLAB called MATLAB Mobile, and then you can access all the phone sensor data from the phone, and then transfer it onto your MATLAB Drive, right? So MATLAB Drive is a online hosting, kind of like Dropbox or Google Drive, right? So you can sort of collect all the sensor data and then send it to your drive directly. In fact, MATLAB and Simulink can also run online, entirely online in your browser. And so, if you don't want to install anything, you can sort of do that entirely through your Chrome browser, for example. Again, this depends on you having the campus-wide license program. And so this is another great way to have students who may not have the necessary or required hardware capabilities to run MATLAB and still do everything remotely online. Right? Cool.
So is Simulink also available online? Can I do my data interface that you just said, like deploying code into my Android device, or is all that available online?
Right. So Simulink is available online. The block diagram interface, right? The generating the code part for your Android phone, I don't know if you can do that entire workflow online. I think you'll need a desktop version to do the generation of code. The interface to build your model, you can do that online. But if you want to deploy it on your phone, you also need the Android Studio backend to be installed and things like that. We unfortunately can't do that online at the moment. So for that purpose, you would need to install.
Does a campus-wide license give access to only MATLAB desktop, where I can install MATLAB in my lab machines, or does it give access to all the students' desktops and also probably online and Drive and all these other things that you're mentioning?
Right. That's a great point. So really, like Spandhana mentioned, the campus-wide license program is access to everyone, right? Access to everyone anywhere. So if your student is working remotely or is studying from another state in the country, wherever they are, they have a license to use MATLAB. They don't have to be on campus. They don't have to be in a lab. They don't have to be anywhere in the vicinity of the campus too. From their homes, they can start working on MATLAB. They can in fact download and install MATLAB and have all the features available wherever they are. So that's the real advantage of the campus program, as opposed to other types of licenses that might be available. And that's really why we're excited about this particular mode of engagement in the online world.
Thank you, Amit.
Cool. So again, in the interest of time, I guess we'll run through this very quickly. And maybe not all of you might be doing this, but for some of you, this might be very, very interesting. The idea is something called auto grading, right? So the traditional way of grading assignments for the faculty in the audience is that you have your students submit their homework. They wait for 1 or 2 weeks, and then they get feedback, and then they work on the next problem, and then go through this kind of process. And then you may have a whole bunch of these assignments that you have to correct at some point in time, right? Where all of them are the same problem solved in different ways, and then you have to spend a lot of time doing this. So instead, the idea of auto grading is when you submit homework as a student, you get instant feedback, and then with that you can improve and learn. And there's no human who's correcting over here, right? So this happens in an automated fashion. And so the dual advantages of this is the student doesn't have to wait for long to get feedback. The feedback is instant. And you as a faculty, if you're a faculty, don't have to manually correct all of these sheets, right? This happens automatically. There's no human in the loop here. Right? So this is really something that we are very excited about. It's a tool called MATLAB Grader. Okay, so I'll quickly try to show you how this works. So this is sort of the MATLAB Grader interface, right? And if you have more questions about this, we are very happy to talk to you. But you can sort of set up entire courses. So this one's a digital signal processing course. You can set up the duration of the course. You can give it a description. You can then set up individual assignments and say, when is it visible to students? When is it due, right? So you can say visible today, due next week, right? How many submissions are allowed by students? 5 submissions only, right? And then you have a bunch of problems here where the student sees this problem description, In fact, there's a learner preview that, this is exactly what the student sees right here. And then the student can write a function or some code to answer this problem here, right? So the student writes the solution. Again, all of this is in the browser directly, right? And then there are these assessments already, right? So this is how the student's code gets run, and then you can see if they got it right or wrong, right? So the student really completes the problem here and then submits, and then they get instant feedback as to, based on these assessments, what they got correct and what they got wrong, right? And so you can, in fact, have entire courses here. So we have 10 lessons here, where there are several problems in each lesson, right here, for example, and right here too. Several problems in each lesson that you can set up, such that the student is actually learning this on the fly, and you don't have to manually answer or grade their solutions, right? We in fact have some problem sets for common courses as well, for signal processing, for controls, for mathematics, and so on. And all of these, again, come along with the campus-wide license program.
Amit, we have a question from the audience, whether this
Yep.
grader system needs license. Is it online or offline?
Right. Great question. So the grader runs online. So this is in your browser right here. So this is entirely on your this is Microsoft Edge, right? So it runs entirely in your browser. So the students really need to have a MathWorks account and then log in, and then they can look at courses here, right? In terms of the license itself, this comes along with your. So if you take part in our campus-wide license program, the grader license comes along with it. So Vinay, if he's around, can probably answer more questions about the program itself if you have more questions later on.
So all the online courses, the grader and MATLAB Mobile, and all these come in the program itself.
That is right. Yes.
Okay. I think grader is an awesome tool, given that nowadays we cannot conduct exams. I want to highlight one particular institute that is using this tool very effectively, and that is, if you've heard of RV College of Engineering in Bangalore, I have personally worked with them, where we've helped them transition all their mathematics courses. That means we have worked on 8 courses in the entire engineering, all departments. So we have enrolled almost 2,400 students. And right from first year, they use MATLAB in their courses, assignments, and now they're conducting examinations as well in Grader. And they have wrapped up their semester with exams in MATLAB Grader, where students attempted answers sitting at their home, and they've been able to close the semester.
Yep, thanks for bringing that up, Spandhana. Yeah, so RV College is a great example where they've done this for first year, right? So for students who don't have, are not expected to have a lot of background in MATLAB, they have also been exposed to this grading tool, and in 2,000 students or so, completely online, and they've been able to run it very well. So we have prior examples of people using this and being successful at using this to run their courses. So yeah, thank you.
We have one more question from audience. They want to know whether MATLAB can run offline or online.
Right. So MATLAB, the program itself can run offline too. So this, in fact, that you see on my screen, this is the desktop installed version of MATLAB, right? And once you install this, you can use it without internet connectivity at all. But obviously, to install, you'll have to download it. So this is the standard kind of version. If you want to run it online, there is this thing called MATLAB Online. Let me try to. That became recursion. So this is matlab.mathworks.com. This is, as you can see, I'm running it on my browser. And pretty much the same interface comes online as well. So there are both, in fact. and they're connected, meaning if there's this thing called MATLAB Drive Connector. It's kind of like Dropbox, where you have the desktop version of Dropbox where you kind of can sync your files between your computer and the internet. You have that too. So that way, your files on MATLAB Online are also available in your offline version too. So that's also an option too. So this is how the online version looks, and this is the desktop version. Okay. All right. So in the interest of time, let me quickly go over some resources that we can share with you. So really, we sort of look through a bunch of these things in terms of solutions for integrating computational tools or computational thinking in your curriculum, right? So we looked at the live editor apps, MATLAB Online, project-based learning, Grader, and so on. So all of these are available for you to transition better into online teaching kind of a mode. And in addition, with the campus-wide license program, Spandhana and I, right, are part of a group called Customer Success Engineering. So we are a group of a little more than 10 now, who help faculty, if you're interested in adopting these tools and using Grader and things like that, we can assist you to do that, right? So we have a fairly large team here in India that can help you do that.
And we come from various disciplines. I come from chemical engineering. Amit is electrical engineer, transitioned into computer vision and an expert in image processing. So we have people from multiple disciplines, robotics and mechanical engineering and so on. So we help professors take their courses in the best way possible using MATLAB and Simulink to their students.
Right. Yeah, absolutely. So we have Spandhana is a PhD in chemical engineering. We have another person who is focused on chemical. We have people doing fluid dynamics and things like very fancy things. So we can definitely be of help to you. So that's it. So if you have questions, sorry we went 10 minutes over. But if you have questions, please do let us know, and we'll try to answer them as we go. But otherwise, that's really it in terms of our presentation. Thank you for your attention.
We have some questions in big data. Like somebody is asking, how do we implement big data in MATLAB? So there is, Nikhil, could you help share the link for our tools for big data solution? So data science is all over the place right now. So, and there's a lot of interest in data analytics techniques, and MATLAB is one of the tools that many engineers are preferring to use, given that it has a very strong mathematical background. So we do have tools for big data analytics, accessing data files from databases and so on. So I get another question on how do we implement big data and which place do we store the data set. So it depends on what type of data you have and where it is stored. If it is in a database, you'll have to access it using querying techniques through the database. We also have questions on, do we have free version of MATLAB without buying license? I think this is something Vinay can answer.
Absolutely. So thank you, Amit, Spandhana, Nikhil. So basically, we went through 2 days of sessions with respect to not only the technical topics of artificial intelligence and model-based design, but also we went through how to teach with MATLAB, thanks to a wonderful session by Spandhana and Amit. So most of these services and most of these resources that are available, we are trying to reach out as an initiative from MathWorks through a program called as Campus-Wide License Program, wherein which we try to reach out to most of our colleges, and then provide them complete support with respect to not only the licenses which are available, but all these resources and the expert advisors from experts like Spandhana, Naini, and Nikhil, Spandhana, Amit, and Nikhil as well. please do, if you have any queries regarding campus-wide license program, or if you are interested to explore about the possibility of having partnership with ourselves and through our campus-wide license program with your college, please do not hesitate to reach out to me or any of us here. So you can actually see the email ID of myself in the top right corner of this window, wherein there is the yellow sticky note. So you can directly reach out to me or any of us, or we have it shown in the screen as well. And please do not hesitate to share your feedback for today's session of day 2, which is also shown in the the sticky note as well. So we'll be happy to take any of your queries one-on-one as well after this discussion. Yeah. Thank you very much.
Thank you, Vinay. We have more questions on any programming languages. What are the prerequisite programming languages that one needs to know to work on MATLAB? Amit, could you help answer that?
Yeah, thanks, Spandhana. Really, I don't think there's any other prerequisite language that you need to learn. MATLAB, in my experience, is as mathematics-like as it can get. So matrix multiplication in MATLAB is, if A is a matrix and B is a matrix, it's A star B, right? Really, it's that simple. So long way to answer your question is, you don't need any other prior programming experience, at least as far as I can say.
You can check out this MATLAB on-ramp course, and it'll give you a good idea of what is MATLAB and how easy it is to use. So it is really not that difficult. I myself, from a chemical engineering background, I saw other people using MATLAB and try to learn it myself. So most of us here are self-taught, and we used internet resources and we got started. But now there's a much more structured approach to get started with MATLAB, like MATLAB on-ramp course. So please check it out. It's very intuitive and easy to use. We have another question on how about chemical process equipments modeling using MATLAB? Do we have a separate package for that? So chemical process equipments itself, we do not have a separate package. However, we have some tools known as Thingsspeak, which is model-based design tools essentially, and we do have some components in Thingsspeak which can relate to chemical process equipments. We have tanks, we have heat exchangers and reactors and so on. And moreover, myself and my other team member, we are building some chemical engineering related models and models for these kind of equipments, which might be useful. So you can reach out to me on my email ID that is shared here. So I'll be happy to discuss more with you about what we have as of now. So we have more questions on whether we could consolidate the sources for learning MATLAB. So definitely we can share this entire presentation with you. We have also listed down all the courses that are available. So you can definitely take a look at that and all the resources that are available. So you can get started from this presentation. We'll be sharing that. Do submit the feedback form. So we have your email IDs, and then we'll reach out to you separately based on your email IDs that you've submitted.
Please do share your feedback in the link. That's how we get access to your email IDs, and we'll be able to send you the presentations there. Thank you. Professor Dinakar, Professor Balamurali, over to you, sir, professors. Thank you.
So thank you very much. It was a wonderful session. The 2 days went well, and the more information has been, the knowledge transfer has been done. As the webinar series name itself says, knowledge 4.0. More knowledge has been translated or transformed to the faculties and students, and even I too came across a lot of new initiatives by MATLAB, and which will be definitely useful for the faculty members as well as students also. So my humble request is to the faculty who are attending this session is, take this forward to your students community and make them to utilize this opportunity available for them. So that is my request from my side, and I thank the whole MATLAB MathWorks team for the wonderful 2-day session on behalf of Chennai Institute of Technology. Thank you very much. Over to Dr. Dinakar.
As Palamuri sir said, I think correctly the Knowledge 4.0 has been taking tremendous effort to enhance the knowledge of faculty, researchers, and students community. And we used to say this is one of the unique and distinct initiative of Chennai Institute of Technology under the guidance of our Honorable Chairman, C.P. Sriram. The way we are saying is, we used to call the distinct people, the experts, those who are good in their field from industry, academia, are being called to share their experience, share their expertise. So like the 2 days webinar might be highly useful to the students, researcher community, and faculty community. And as I said, this webinar will be highly useful to go for a good classroom teaching for the teachers or faculty members, and for researchers, it will help them to get into further research, and for the students, it will help them to go for final year better projects. So thank you so much for MathWorks for giving a very good opportunity for the students and faculty and research community for learning. And thank you on behalf of Chennai Institute of Technology. We want to collaborate with you in future, and we would like to hear more things from you. Thank you so much. We thank Dr. Spandhana, Mr. Amith, Mr. Nikhil, and Mr. Vinay for their wonderful sessions. Thank you so much. And the way in which it has been organized is excellent. The way today's session has been brought is very good observation. Thank you so much.
Thank you very much.
Thank you. Thank you. Thank you.
Thank you.
Thanks to the participants.
Thank you, professors.
Bye.
Thank you so much. Look forward to collaborations. Thanks.
Participant, thank you so much. So hope this 2 days webinar might have been highly useful to people. And so please keep on visiting our institute website, chennai-technology.com/chennai-technology.com/webinar, or you can visit chennai-technology.com in Facebook, Instagram, or Twitter. Will help you to know about the forthcoming webinars. And also tomorrow, a wonderful webinar has been planned, which is going to be handled by Dr. Kaddababu, Director of IPR, Anna University. So he will be talking about IPR, which is one of the needy webinar for all the researchers and students community and faculty also. So those who want to register, so you can already the information has been put in the website, college websites, and all social media. So you can avail the registration link and you can go for registration. That will be highly useful. And from for the mechanical, civil engineering faculties, researchers, and students, from 1st 1/7/2022, 6/7/2020. One webinar series, that is lecture series on mechanical behavior materials, has been arranged. So an eminent professor, Professor Dr. V. Balasubramanian from Annamalai University is going to handle the sessions. So that will be per day, 1 hour the session will be. Most probably almost all the contents in the aspects of mechanical behavior materials will be covered. So that will be a great learning for all. So those who want to register, you can go out of registration. The details is already available in the websites. Okay. So not only for civil and mechanical, even electrical and electronics people also go on with that if you want to learn the mechanical behavior. Because nowadays, so new materials are being introduced in the design of electrical circuits, and you can IC chips. And VLSI, all the chips, new materials are being utilized. So in order to understand the better behavior of the materials, you can go for the registration if you want. Okay, and but preferably mechanical and civil engineering students will get more advantage. Faculty or researchers, but you people also you can learn you to understand the better scenario. Okay. And thank you so much. So we will meet in the tomorrow webinar. Thank you so much. And as I said, certificate will be sent to your registered mail ID. So and the help from your end is so properly enter the mail ID and name in the webinar chat link. Okay. So thank you so much. We will meet in the tomorrow webinar.